Good afternoon. Welcome. Welcome. My name is Amanda Woodward, and I am the Dean of the Social Sciences Division here at the University of Chicago. And it's my honor to welcome you to the inaugural Imberman Lecture in History, marking the launch of a new scholarly event that exemplifies the University of Chicago's intellectual tradition. In addition to all of you in this crowded room in person, I would also like to welcome those who are attending via the live stream. The Imberman Lecture in History is in history, but it reaches really broadly across disciplinary boundaries, and we can see that in tonight's speaker and also in the attendees here, who include political scientists, political economists, sociologists, and so many others, as well as historians, and faculty, graduate students, college students, alumni, and friends of the university. This event is made possible through the generosity and vision of the Imberman family, who have established this endowed annual lecture in memory of Eli Woodruff Imberman, who earned his PhD here in history in the early 1970s. It's a gift that reflects Mr. Imberman's love of history and scholarship and the intellectual home that he found here at the University of Chicago. As his son, Lane, who is here with us this evening, remarked, Woody believed that the present could only be understood through the deeper currents of history. There is perhaps no one better than Nobel Laureate Joel Mokyr to help us see our current moment through the same lens. I'm very grateful that Professor Mokyr is joining us as the inaugural lecturer. It's a wonderful beginning for this series. Appropriately, the home department for this lecture is the Department of History, a community of scholars known for their methodological rigor and for their persistence in looking and thinking globally about history. And that is a perspective that is so important for understanding the forces at play in history. Now it's my great pleasure to introduce the University of Chicago president, Paul Alivisatos. Paul is the John D. MacArthur Distinguished Service Professor in the Department of Chemistry. He's a preeminent scientist and innovator whose pioneering work has had important application and been honored by a number of awards, including the 2024 Kavli Prize in Nanoscience and the Enrico Fermi Presidential Award. Paul is also a fierce intellectual and ambitious intellectual leader of this university. And I am deeply grateful for the vision that he brings to thinking about the future of this very unique and precious institution. And I'm especially grateful that he's joined us today. Paul.
Good afternoon. And thank you, Amanda, for your very kind words. This is indeed an amazing and wonderful and precious university, so it's very kind to hear those words from you. And thank you, in turn, for your leadership of the Division of Social Sciences, which is such an amazing part of the vitality and spirit of discovery of this university. It is also, I want to join Amanda in saying how excited I am that we now have the Imberman Lecture. This is a really big deal. Lecture series like this matter. They do bring us together, and this is an event that's really for the whole of the university. I think it's so exciting that history has a lecture of this kind now to bring us together each year to learn. And to have a scholar visit us and bring forth the different aspects of that discipline. And of course, the Imberman family, I want to thank you as well. It's just a great lecture. It enables the university to really have a public-facing lecture as well, not just across the university itself, but in a more public way. And Professor Mokyr, I was reading about how you described the time of the culture in the time of the Industrial Revolution and the role that private citizens played in interacting with each other, and perhaps also to some degree the role at that point in time, at least, of Cambridge and Oxford as having been notably absent in the development of that culture. And I think we all recognize that for this university, we would love the power of ideas and the culture of really thinking about what helps society to thrive to be something that we're in deep dialogue with private citizens and the public at large about. So it offers that opportunity as well. And I think that's absolutely terrific. So the lecture, I think, has many bases on which it can draw us in. And when we see history, economics, political science, and philosophy brought together in the service of understanding society's deepest problems, why, that's just absolutely incredible. So thank you, Imberman family, and thank you, Professor Mokyr, for being here. And I'd like now to introduce Professor Stephen Pincus. Professor Pincus is himself a distinguished historian of political economy and institutions. His work exemplifies the university's interdisciplinary spirit. I can attest to this because I've been in conversation with him about how the different parts of the university can come together to build exciting new programs for the future. And he's just such an interdisciplinary thinker. He moves across all kinds of subjects in beautiful ways. So I'm excited about that. And he's the ideal person to frame things. So Professor Pincus, up for you.
So let me begin by thanking the president for and the university, but also the Social Sciences Division and Dean Amanda Woodward for its partnership in organizing tonight's event, and reiterate how excited the Department of History is to host this inaugural Eli Imberman Lecture. This inaugural lecture will, we hope, invigorate an ongoing conversation at the University of Chicago to understand how ideas and institutions shape economic life and culture. The Imberman Lecture dovetails with our ongoing cross-disciplinary institutions initiatives spearheaded by Nobel Laureate and University Professor James Robinson, and including colleagues from political science, social thought, and history, which studies how the historical emergence, development, degradation, and transformation of institutions play a significant role in shaping knowledge, incentives, possibilities for prosperity, as well as social outcomes in our world. This new initiative continues the University of Chicago's long tradition in leading these transformative conversations with iconic strengths in economics, political science, history, and policy, and with a distinctive tradition of interdisciplinary inquiry into society's biggest problems. By sustaining these conversations across disciplines around shared concerns and issues, we enable a kind of intellectual innovation that was formative at the birth of the social science fields, but is becoming increasingly, alas, rare today. Building on these foundations, we aim to establish the University of Chicago as the leading force in identifying and strengthening the institutional structures that enable prosperity and liberty. So our inaugural Imberman lecturer is Joel Mokyr, the Robert H. Strauss Professor of Arts and Sciences at Northwestern University and the 2025 winner of the Nobel Memorial Prize in Economic Sciences for having identified the prerequisites for sustained growth through technological progress. His research is primarily concerned with the understanding of the economic and intellectual roots of technological progress and the growth of useful knowledge in European societies. He is a fellow of the American Academy of Arts and Sciences, the Econometric Society, and the Cliometric Society, as well as the British Academy, the Italian Accademia dei Lincei, and the Dutch Royal Academy. He has been the president of the Economic History Association, editor-in-chief of the Oxford Encyclopedia of Economic History, and a co-editor of the Journal of Economic History. Professor Mokyr's impressive academic career has been remarkably productive and incredibly influential. The first two books of his that I recall reading were his Industrialization in the Low Countries, based on his Yale doctoral dissertation, and Why Ireland Starved, both of which remain standard reading for anyone interested in European economic history today. However, in many ways, the series of books, The Gifts of Athena, 2002, The Enlightened Economy, 2009, and A Culture of Growth, 2017, had a truly transformative effect, not only on economic history, but on history in the broadest possible sense. These works demonstrated the intimate relationship between cultural, intellectual, and economic change, forcing economic historians to reckon with ideas and compelling serious intellectual and cultural historians to engage with economic history. His most recent book, Two Paths to Prosperity, Culture and Institutions in Europe and China, 1000 to 2000, it's a co-authored book, which will be discussed at an event tomorrow at the Harris School, continues these themes. Those of us interested in economic history, the history of political economy, the relationship between historical change and institutional change, owe Professor Mokyr an especial debt of gratitude. His energy, his scholarship, his own institution building, both at Northwestern and through his leadership of the Economic History Association, played a huge role in keeping the study of economic history alive when it was marginalized in both economics and history departments. That this is no longer the case, that the last 2 Nobel Prizes in economics were awarded to scholars with deep interest in economic history, owes a great deal to Professor Mokyr's efforts. I now welcome Professor Mokyr as our inaugural Imberman Lecturer and very much look forward to hearing about the market for ideas then and now. I'm sure we'll all be in for a really great treat. Thank you.
Yeah, so good afternoon, everybody. It's a great honor to be the inaugural Imberman Lecturer. It's particularly suitable that I'm giving this talk here at the University of Chicago because the concept of a market for ideas actually originated here, associated with 2 names you will all recognize, people named Ronald Coase and George Stigler, both of whom wrote important contributions to the idea of market for ideas, if that's. And I'm going to take them up on this and hope I do some justice to their notions. But I'm actually going to look at the market for ideas in the past and then say something about it today. So there we go. So the structure of this talk is basically 4 parts, which is what you'd expect anybody talking about a market. I'm going to talk a great deal about the supply side, a little bit less about the demand side, and then I want to talk about the market itself, its efficiency and its capability of allocating resources correctly. And finally, I'm going to jump a few centuries and see to what extent what I've said about the past applies today. So, is the concept of a market for ideas actually a useful concept? And of course, in some ways, it isn't really what we think of as a market because there's no real market clearing price in this market for ideas in which the market is in any sense can be seen to be an equilibrium, which is of course what every economist loves. But look, knowledge and ideas are valuable and they're scarce, so they're goods. But it's the mother of all public goods, as I will show in a minute. The market for knowledge is about the most failure-prone of all markets imaginable. Even more so than the marriage market, but I'm taking the Fifth Amendment on that one. But of course, markets and institutions, which have become very much a standard part of economics, are closely related. All markets require institutions that underlie, that sort of set the rules of the game that determine incentives and behavior. And that's true a fortiori for the market for ideas. Yet the rules for the market for ideas differ from most other markets, as I will show. And so first, what exactly is the nature of a transaction in the market for ideas? And as I see it, an agent, an individual, has a new idea and tries to persuade potential buyers to accept his ideas. So if he or she succeeds, they've made a sale. That is to say, they may also sell a book, by the way, but that's incidental. The main thing is you're trying to convince somebody of your new idea. In fact, that's what I'm doing this afternoon, if you want, but we all do this. Every academic, that's what they actually do. So how was this done in the 16th century? And the answer is, of course, that most of it was done by writing books that others read, or by corresponding with others, scholars like it, or in one case at least, nailing 95 propositions to a church wall, which is sort of an odd way of doing it, but in his case it was effective. And so, as I will argue at the end, it's not really all that different today. Also, the technology, of course, has changed a great deal. What I'm going to argue, of course, and that's what sort of the bottom line, is that modern economic growth is in large part, not exclusively, but in large part, driven by changes in the market for ideas in early modern Europe. And of that kind of knowledge, the most important part is what I call useful knowledge. Now, that's a bit of an, shall we say, a value-laden term, because it includes most of it, what I think is sort of concerns nature and natural forces. So it would be, roughly speaking, this sort of union of the sets of science and technology, and would not include the humanities, although you could argue that that's useful too. But in the 18th century, that is what people thought of as useful knowledge. So, useful or not, it's a market, as I said, prone to a variety of market failures, and that is sort of what makes me sort of think about this. So the first thing, of course, is that knowledge is sort of a classic public good, right? It's non-rivalrous, meaning, which is a classic property of public goods, meaning basically, for those of you who don't remember this from your introductory economics, it's essentially, if I give you some, I don't have any less myself, right? So that's what non-rivalrous means. It's very costly, and in some cases impossible, to exclude others from acquiring it. And so property rights in knowledge and owning it are, of course, problematic. And of course, what that means is that it's very complicated to reward people to make major contributions to useful knowledge. So how do we incentivize intellectual and technological innovation if there is no way for the people who generate it to get rewarded, at least directly? What's more, useful knowledge, in addition to being having these two sort of top public goods properties, also has major positive externalities. And these externalities are both vertical and horizontal. You know, vertical in the sense that, you know, everybody who comes up with a new idea stands on the shoulders of somebody else who was there before her, and horizontal in that in many cases discoveries in science and inventions in technology affect things next to them that through hybridization or complementarities or other forms of interaction. And finally, of course, it is driven with uncertainty. Somebody comes up with new knowledge, proposes a new idea in physics, in chemistry, in astronomy, anywhere, okay? Is it correct? Is it really new? How can we tell the wheat from the chaff? And when is information disinformation? And how do we recognize charlatans, fakes, and quacks? These are all major sources of uncertainty. To make things even more complicated is a question of this is a market that has serious barriers to entries and sometimes creates monopolies. Most people who make good, important new contributions, of course, have to invest very heavily in their human capital before they can refine and package their idea to be market tested. Yet it's important for this market to actually have entry and exit and not to be too concentrated or too monopolized. So that's an issue as well. Now, in many cases in history, of course, the market for ideas turned into something which I'd call a quasi monopoly, which usually had bad consequences. So you can think of the medieval Latin church as such a monopoly, or, you know, across Eurasia, the Chinese imperial examination, the Keiju, which created another one, which is Neo-Confucian philosophy. And worst of all, of course, was the Soviet Union and its commitment to things like Lyashenkoism and the triumph of charlatanry in that country. What's more, not only that there's issues of competition, there's issues of resistance. There is significant resistance to intellectual change due to the fact that scholars have a fixed investment in their human capital, and if new ideas overthrow that new capital, you will find resistance, okay? Max Planck's famous statement that science advances one funeral at a time is a symptom of that, or the many Max Pettenkofers in the history of science and medicine. Max Pettenkofer was a German doctor who resisted the germ theory of disease and famously proved it by drinking a glass of cholera-contaminated water in his lab in Munich and didn't die, which he argued disproved the germ theory. Thank God he too died and science advanced another funeral at a time. Resistance to intellectual innovation then is fueled in part by incumbents protecting their intellectual rents, and in part just simply driven by what we psychologists would call confirmation bias. Okay, there's many examples I could spend the rest of the afternoon here talking about. That James Watt himself, the great inventor, in the end objected strongly to high-pressure steam engines, and Einstein, after helping to found quantum theory, famously rejected the Copenhagen interpretation and its idea of fundamental indeterminacy. So, I mean, resistance can be found at the highest level of science and technology. Now, the issue of incentives in the absence of appropriability is a really hard one. How do you incentivize people to come up with new ideas? If ideas can't be owned, how can intellectual innovators and inventors be compensated and rewarded for their efforts? And so let me say something about the emergence of the modern market for ideas. So my view is, and other people might disagree, that its current features emerged in the late Middle Ages and the Renaissance, that it was, certainly in Europe, was decentralized and competitive, and it's developed over time. Obviously, these things took many decades, but over time, it developed a bunch of characteristics that we still have today. The first most important one, perhaps, is open science. That is to say, if you have a new idea, you don't keep it secret in a drawer, but you place it in the public realm. Some kind of sort of premature or early version of publish or perish, I suppose. Secondly, it observed, I put more or less there because we all know of cases if it didn't quite work, but at least in principle, it observed priority rights. So the person who first came up with the idea had that idea attached to her or his name. To my mind, maybe the most interesting one is the complete abandonment of ancestor worship. The British Royal Society famously has, its slogan is in nullius verba, on no one's word. And eventually, at the time that the society was founded in 1660, by that time, most of the great authorities of Greek and Roman science had essentially bitten the dust. And I'll talk about that a little bit more in a minute. Then what the market for ideas, it doesn't just create and submit ideas, but it assesses and evaluates ideas of others. And this creates the main outcome that sellers craved, which was reputation. Finally, the market was transnational and trans-religious. It's very hard to see that national boundaries mattered a lot in this case, which is actually a good thing. And finally, it was, and I'm saying this with some hesitation, egalitarian and meritocratic in the sense that you did not have to be some kind of nobleman. Now, that doesn't mean that, the peasantry, which is, the vast bulk of the population anywhere in Europe, maybe with the exception of the Low Countries, that the peasantry had access to it because, you have to be not just literate, but you had to, certainly in the 16th and early 17th century, you had to have Latin. And so the people who didn't have access to education obviously were excluded. But among the rest, I would say nobility and birth mattered less than almost in almost any other part of society. So the result is that between 1500 and 1750, a stream of truly radical new ideas were proposed in the market for ideas. And we all know who they are, I just threw out some names here, but anybody can add to that names. In religion, of course, the Reformation, and in philosophy, the great philosophers like Spinoza, Descartes, Bacon, and on, all the way down to Hume and Kant, if you want. Many other radical thinkers challenged incumbents in the market for ideas in various areas. Okay, in medicine, particularly Paracelsus. In astronomy, of course, Copernicus and his followers. Galileo in physics, Stahl in chemistry, on and on and on and on. And so we can think of these people, and I have written about that, as cultural entrepreneurs. And because not only that they put new ideas in the market for ideas, they actually sort of provide new menus of how to think about the world. Now, of all the ideas that I think matter for the subsequent development of Europe, but not just economic development, but primarily so, is the idea of progress. And so from Bacon on, he and his followers supported the idea of progress and that it could and should be brought about by useful knowledge, that is to say, roughly, science and technology. So here's one example of that I kind of like. This is the great mathematician Blaise Pascal, who wrote in 1647, and he wrote about this sort of controversy about atmospheric pressure and the existence of a vacuum, which was just sort of had been proposed earlier. And so he is one of the first to propose a really clean and explicit formulation of the cumulative intellectual progress. And so his passage essentially argued that we could think of humanity as a single person who lives forever and continually learns. And so humanity collectively accumulates knowledge across generations, and then later generations inherit that, and hence science progresses over time. And this, of course, idea is sort of the strongest and most explicit challenges to the traditional authority of classical times. And so what happens then is what emerges, this wonderful debate in the market for ideas between what the French call des anciens et des modernes. So this famous querelle, this famous fight between them emerges in the second half of the 17th century, maybe a little bit earlier. By 1700, my view is, and somebody might disagree, that this debate is basically over, particularly after the publication of Principia in 1687. And the market for ideas really starts increasingly about not whether we should use useful knowledge to advance society, but how this should be done. And I think that is basically the end of that. So here is one famous example of somebody, this is after Pascal, this is the Charles Perrault, who's mostly famous for the codification of folk tales. But he was also a great I would say, proponent of this sort of abandonment of intellectual worship. So he basically claimed in this book that the best time in the world in human history was, surprise, surprise, the rule of Louis XIV. Flattery was not invented in our time, and that basically, if the ancients like Aristotle achieved greatness, so can modern. But because knowledge is cumulative, and that of course came out of Pascal and others, we know what they knew, but they didn't know what we know. That's sort of the recurring themes in this idea of progress. And so very much like Fontenelle in France, Woodward in England, and so on. And I think this idea became foundational in the Enlightenment. And so to come back to the question of how do we incentivize people to write books that propose new ideas, in philosophy, like these guys, or in other fields. And so what I'm proposing here is that there was something of a bifurcation of incentives that happens roughly after 1500, but I wouldn't want to put my finger exactly on the exact time. And I'm going to use a distinction that I've proposed earlier in my 2002 book, which is between propositional knowledge. Not my idea, by the way, I stole it from the epistemologist. But the idea is between propositional knowledge, which is essentially science plus, which means it's more than science, it's things like geography and so on, but essentially it's knowledge of what, if you want, and then prescriptive knowledge, which is technology plus, And basically what prescriptive knowledge should be thought of as a set of recipes. How do you make something, all the way from how do you make a steel ingot to how do you grow wheat and how do you build a chimney and so on and so forth. So the set of incentives sort of bifurcates in the following way. Prescriptive knowledge, that is to say technology, is normally rewarded through what we call in economics high-powered incentives, which means essentially that there's a close correlation between social benefits and rewards mediated by the markets for goods and services. Propositional knowledge, which is science and mathematics, less obvious because there's no obvious market test, right? I mean, you prove a theorem, how would we pay you in proportion to the importance of the theorem? So let me first talk about prescriptive knowledge. And here there is one of the great contributions of European to the thinking about these matters, which is patents. So first patents can actually be found in Venice in the middle of the 15th century. Certainly before 1700, both England and the Netherlands had patent systems. And in France and North America, they were introduced almost immediately after their respective revolutions. And I would think that the idea that patents would be an incentive for people to create innovation sort of matures during the sort of 18th century Enlightenment. There's a very nice write-up of it in Adam Smith's Lectures on Jurisprudence, and a whole bunch of other people made the same point, and also people against it, but essentially that's what it was. But by and large, the driving motive for most inventions is money. And how this creates all kinds of interesting ironic paradoxes, particularly the fact that despite the fact that this was believed to be the great stimulus and promoter for technological change, in fact, most of the important inventions of the Industrial Revolution, with some exceptions, actually were not patented at all, or the patent for one reason or another failed to yield much revenue. But that's, I think, just an irony of history. Now, in addition to patents, there's a whole range of other sort of rewards and incentives that the system produced over time, okay? One of them is simply securing temporary exclusionary rent by keeping it secret. Now, that's a problem if it can be reverse engineered, as we all understand, but in some cases that actually, of course, worked. The other thing is just first mover's advantage. If you're the inventor, you get some time until your competitors can jump into the market, and it's possible, not always guaranteed, that you will get enough of these temporary exclusionary rents to cover your costs, okay? Then there are prizes that were promised by governments for people who made particularly important inventions that turned out to be very useful to the realm. So British Parliament voted on a couple of these prizes for people who had somehow come up with an important invention, like Henry Court, and basically never made any money out of it. So the Parliament would get together and say, well, this guy really came up with something very important, let's vote him a pension. I think the biggest one of all went to Edward Jenner for his smallpox vaccination, £30,000, which at the time was a fortune. Then there are, in few cases, there are ex-ante prizes for inventors. So the most famous of these is, of course, the Board of Longitude Prize, founded in 1714, for somebody who could come up with a device that will allow ships to determine their longitude at sea. There was another one, famous one in France, promised by Napoleon, by the Société d'Encouragement pour l'Industrie Nationale, for mechanical linen spinning, which was a hard problem to solve. And somebody actually wanted this guy, Philippe de Girard, but unfortunately, by the time that his machine worked, it was 1812, and Napoleon was in Russia and not in a mood to pay inventors if he couldn't. And then there are, of course, and this is where there's some overlap with propositional knowledge, particularly in engineering, people were actually trying to establish a reputation. So they didn't patent anything, they didn't keep anything secret, but they wanted commissions. So people like John Rennie and John Smeaton and other engineers, basically, they were in it for the money too, But for them, the best thing was actually to get a reputation so that they would receive commissions from people. And finally, there are a few inventors who got patronage jobs. That was, I think, by this time fairly rare. Now, with propositional knowledge, with knowledge of what, it's more difficult. Because, as I said, the incentives are low-powered. And so, you can come and convince somebody that you have a good idea, and that's what happens in the market for ideas, but he's not going to pay you for it. You're going to say thank you if you're lucky, or give you a footnote if you're very lucky. And there's no easy way of monetizing it. So why bother? And so the Western world, more so than I think any other civilization, it says at least implicitly or intuitively recognize this market failure, and they created actually a host of incentives to create new scientific ideas, and they fall into sort of 5 major categories as I see it. The first is patronage, and I'll come through each of the fame and peer respect, intrinsic motivation, region, and altruism. Okay, so let me talk about each of those. Let me first talk about patronage job. This is an age of patronage, this is early modern Europe. Most intellectuals, and this is not going to come as a surprise to, I think, anybody in this room, basically, what they require is what you think sort of a comfortable life in which they can do their work with high degree of certainty. So, of course, tenure jobs at the university meet that criterion. In those days, people were looking for patronage appointment in courts of kings, emperors, popes, rich merchants, and so on and so forth. And so I spent some time looking at the leading intellectuals of Europe in what you call early modern Europe, and there were very few of the major figures of the scientific revolution that were altogether indifferent to patronage positions because they needed to survive. There were a few, of course, such as the great Robert Boyle, who was one of I think the second or the third richest man in England, so he obviously didn't need a patronage job, and a few others like Spinoza, who just wasn't interested in this stuff. But they were exceptions rather than the rules. Almost everybody else was looking for some kind of patronage job. Even the great Newton, of course, himself became eventually master of the mint, which was a patronage job, even though he worked very hard at it. So here's one famous example. This is the story of René Descartes, who also was actually financially independent, not quite as rich as Boyle, but he was, he didn't need the money. But Queen Christina of Stockholm, who thought that this would add glory to her court, invited him to go to Stockholm in 1649. And she was sort of intellectually ambitious and interested in philosophy, a bit of a dilettante, I suppose, but still. And Descartes already had a big reputation thanks to his méditation, and he was a prize catch. So he didn't need the money, as I said, but he went because he was flattered and because at the royal court came with high social status. It was actually a bad idea because he caught cold there and actually died fairly soon. Then there's fame. And so, this is by and large, I think, what you'd call a non-pecuniary incentive. Reputations among your peers make you feel valued, okay? And they may appear directly in what we call in the utility function, right? So people actually just want that. And it's probably particularly prominent among intellectuals. And so what you see is the emergence of very successful academics. The most successful of them become celebrities. So take this, okay? So Newton was one of the most famous men in England, and the irony is there were probably no more than 100 people in all of Europe who could actually understand Principia. When he died in 1727, tens of thousands of people passed by his body lying in state in Westminster Abbey, because he was an academic celebrity. There were a few others, but he was maybe the most prominent example. And so superstars like that became role models in the 18th century. And in fact, there are many young scientists, even in fields outside physics, who wanted to aspire Newton and, so to speak, be like Ike. And so this is an age of the emergence of superstars in the market for ideas. And there's a wonderful paper also written at the University of Chicago by Sherwin Rosen called The Economics of Superstars, now almost half a century ago, who actually pointed out the conditions needed to create these kind of global superstars, not just in intellectuals, but basketball players and violin players and so on and so forth. So Sherwin actually explained precisely what the conditions for the emergence of superstars were. And of course, one of the most important things, extending your reach to a large audience. And, that is precisely what the printing press did, of course. That you could print a large number of books and send them around across Europe, and that's precisely what happened. There are some other conditions, that the product of an individual is convex in output, but so on and so forth. But that, in some sense, didn't matter for this particular case. But the printing press did. And so the marginal cost, so to speak, of spreading new knowledge is coming down, and that helps to creating these superstars. Now, if you push me hard enough, and this is sort of just a footnote, there were a few, quote, intellectual superstars in the Middle Ages, particularly, of course, Thomas Aquinas and Peter Abelard, but really the printing press is what did it, and it created these true intellectual superstars that were so widely recognized that they could write their own tickets to almost any job. So here are some more superstars if you want. And then, of course, there are a whole bunch of intellectual innovators who may have been stars even if they weren't superstars. And one of the nice things of being a superstar is not only that you got a patronage job, but it also protected you against reactionary forces that fought to protect society from heresy. And so if you were, an intellectual superstar, and somehow the political climate changed for the worse because that particular ruler was reactionary or didn't like your work for some other reason, you could pick up your suitcases and go, and somebody else would offer you a job. And so what I want to stress here is that superstars are a remedy for the failures in the market for ideas, because lack of appropriability of most ideas means that society systematically underproduces ideas. That was pointed out, in more than half a century ago by Ken Arrow, and I think it's become part of the sort of consensus. But if there are a few superstars and their payoff is salient in the sense that everybody knows about it, then what you're going to get is a very large number of people trying to imitate them and see, maybe I'll buy a ticket in that lottery, so to speak, and I may become, like Newton or Einstein or, somebody like that. Now, people tend to overestimate their own capabilities, as Smith pointed out famously. But what you still get is the hope that you will become a superstar may actually produce a great deal of valuable knowledge. Even so, at the end of the story, there's a disappointed scientist who dies without having become a superstar. But in some sense, that may be bad for them, but it's good for society, because if their advances in useful knowledge have positive spillovers. So what is it that people want? So here's a famous quote from respect by peers is important. So this is a quote from the Theory of Moral Sentiments, in which Adam Smith tries to come up with sort of what's motivating people with ideas. And so, or rich people. And so the main thing you want to be is not so much, is it the necessities of nature? He says, he says, the wages of the meanest laborer can supply them. I'm not sure that's totally true, but never mind that. But basically, what it is reputation in your environment. So the rich man feels that people are naturally drawn upon him, the attention of the world. Everybody's eager to look at him. His actions are the object of public care. Scarce a word, scarce a gesture can fall from him that is altogether neglected. Now, this is what in some sense, respect by peers really mean. And so, as to summarize this point, what people wanted was credit, to be credited for a new idea, not necessarily profits. And in fact, that is becoming very, very common. And even if you weren't interested in the money, you wanted to be recognized as the person who came up with that idea. So Boyle, whom I mentioned earlier, clearly didn't need the money, but he still was annoyed by people essentially using his work without attribution. Who isn't? And he instructed the secretary of the Royal Society, Henry Oldenburg, to produce a catalog of all his writings, to make sure that people knew where these ideas came from. More famously, perhaps, is of course the famous priority fight between Leibniz and Newton about who invented calculus. And neither of them, by that time that fight emerged, both of them were already superstars. But they still had, and this is going to come as a shock to you, all of you, but these academics still had egos, and they wanted to be recognized as the people who invented this or the other. Now, even in our own time, this is still a major consideration. This is just a footnote, but some of you may remember this. This was in the Nobel Prize in 2003 for physics, which was given by for the development of MRI, but they excluded, the Nobel Committee, for its own reasons, gave it to two people and excluded this guy, Raymond Demedian, who had actually made major contributions to the MRI technique and then went into business and made a fortune. And maybe they held it against him, who knows. But Demedian, who God knows didn't need the Nobel Prize money, published full-page ads in all the major newspapers complaining that he had been robbed of his Nobel Prize. And of course, what he really was interested in is in the signaling value of that, not for money, but for his respect of peers. So let me say something about intrinsic motivation. So I talked about peer recognition, I talked about patronage, let me talk about intrinsic motivation. So in theory, what we mean by intrinsic motivation is some internal motivation without any obvious payoff. So the best analogy I can think of is sort of like solving a crossword puzzle, right? So there's some issue that interests you, and you roll up your sleeves and you're going to solve it. And of that, I think curiosity is one of the more interesting sort of driving forces. It's a form of intrinsic motivation, still drives useful knowledge in many, many areas, clearly. And the history of curiosity in the West is kind of interesting. It used to be a vice. So St. Augustine actually defined it as one of the vices, and even Aquinas, many centuries later, still was very ambiguous about it. And the medieval church regarded it as sinful. That changed exactly in the period that I'm talking about. So, here are two of the sort of heavy hitters of that period. Both of them happen to be English, but it's not just in England. But Francis Bacon explicitly warns the readers that curiosity is a good thing. And he says, don't fall into the error of thinking that, quote, the inquisition of nature is in any part interdicted or forbidden. And then he cites this lovely line from Proverbs that says, it is the honor of God to conceal a thing and the honor of kings to investigate them. So you can look that up. And he interpreted that to mean that curiosity was a good thing. Thomas Hobbes went even further, and he defined curiosity as the desire to know the cause of thing. And then he defines it sort of as, it is a lust of the mind that by a perseverance of delight in the continuum indefatigable generative knowledge exceeds the short vehemence of any carnal pleasure. I don't know about that, I mean, I'm taking the Fifth Amendment on that, but maybe Hobbes knew something we don't know. But clearly, there are cases in which it's very hard to see anything but pure curiosity. So one example is Henry Cavendish, who was an 18th century, another wealthy aristocrat, discovered hydrogen, among others. But he was really reluctant to publish anything. He had a few friends who pressured him, and so he got a few things published. But many of his most important papers were actually discovered many years after his death and published posthumously. Let me say something about religion. because religion has a sort of a, I think, certainly among the general public, sort of a bad name as something that incentivizes science. So there's a wonderful paper by my friend Roland Benabou and two co-authors who actually points as a very beautiful formal model pointing out how religion and science sort of are, so to say, hostile to one another. But in fact, history of Europe shows that this story is more complicated. For one thing, even in the Middle Ages, you know, much of the scientific writing and research and development, such as it was carried out by men of the church and by monks. If you go after the Reformation, Catholics actually were the ones that set up a great deal of institutions that wrote and taught science, particularly, of course, Jesuits, as is well known. And some of the leaders of these Jesuits, like Christopher Clasius and Athanasius Kirchner, actually became great scientists themselves. There were other people in the regular clergy, such as Imberman and Campanella, and then some other priests, like Copernicus himself, Gassendi, you know, others. And then, of course, there's the famous Merton thesis, which essentially pointed out that some religious groups, and he was talking about the Puritans, but I actually think the group is larger than that, basically felt, you know, that all they did think about is, of course, God and what he meant, what he was, and so on and so forth. And one of the conclusions that the Puritans came to is that God is so inscrutable that we can only know him from his works, and hence we should do science. That's the sort of Merton thesis in a nutshell. And in fact, that is a motive. I mean, you look at somebody like Michael Faraday, who belonged to a small, very religious sect, and essentially he did it because he thought that this would be a religious act, you know, glorifying the wisdom of the creator, that kind of thing. Now, it's also true, of course, that by the time of the Industrial Revolution, religion was declining as a motive for research, and even so, the famous Laplace Napoleon anecdote is apocryphal. For those of you who don't know it, this is a famous story about when Laplace wrote this magnificent book of physics that essentially formalized much of what was known about astrophysics at the time. And then he was invited to the emperor's palace, and Napoleon said, you know, Mr. Laplace, where in your entire story is God? And Laplace famously responded, I have had no need for that hypothesis. Now, it turned out he should have said it, and he could have said it, but he didn't, so like many of these stories. But it's true, of course, that at that time, physics is separated from metaphysics. And finally, there's altruism. And you want to do something good for the human race. And there have been clear-cut cases in which people are essentially were driven to invention because they wanted to do something for the greater good. Sometimes it's humanity as a whole, sometimes it's their country, you know, like you know, the nitrogen fixing process invented by Fritz Haber before World War I, which was, you know, doing not for mankind, God knows, but for Germany. Okay, but if you think of people like Jonas Salk and Albert Sabin, you know, for instance, who, by the way, neither of them ever won the Nobel Prize, but Salk was still voted a joint resolution, I mean, clearly was respected. But I think their main driving fact was, in fact, doing something good. Now, there are other cases in which people claim to be pure altruism, but in fact, you dig deeper and it turns out that many of them, this altruism was not entirely devoid of a need to be recognized. And so I'll skip over that. So for most people, I think the motives were some kind of mixture. But the most important thing is, I think, that there were enough incentives by these 5 combinations to create a scientific revolution, to create what came after it in the 18th and 19th century. So I talked a little bit about this supply side of it and how we incentivize people either to invent or to come up with new ideas. Let me say something about demand. So the demand side is in large part, I think, generated by growing interest in novel ideas because people had sort of dropped their neophobia altogether in Europe. So there's this famous quote from Dr. Johnson, this is exactly on the eve of the Industrial Revolution, and it's, the world is running mad with after innovation, all the business of the world, tack, 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 tack. Men are to be hanged in a new way, and I don't know if whether we shall not in time come to be married in a new way. Not a bad prediction here. And, you know, and here's somebody writing 60 years earlier, also the humor of this age is to despise what is done before. So, you know, people became, there was a demand for novelty. And I think people in a position to practice patronage clearly wanted the most innovative and creative of people to be at their court. But there's something deeper than that, ladies and gentlemen, which I really want to lay out here, but it's important. And that is something I alluded to before. Europeans, after 1450, had become increasingly critical of the conventional wisdom that was bequeathed to them from antiquity, embodied in the writings of Ptolemy and Aristotle and Galenus and so on and so forth. This criticism, this skepticism soon turned into, I'd almost say, disrespect. Having lost their trust in the authorities, they were looking for newer and more accurate forms of useful knowledge. So here's one example. Some of this may not be all that well known. This is Niccolo Leoniceno, a doctor in Padua, I believe, and who basically took on one of the great masters of classical knowledge, Pliny the Elder, who wrote this sort of encyclopedia of everything you want to know about every animal and every place and every plant and so on and so forth. And the book was actually called On the Errors of Pliny the Elder. He focused on the medicine part, but there was more in it than actually in your care. And he is one of the early birds in this, but by the 16th and 17th century, essentially one after the other, people show ever-growing disrespect for the knowledge that we think of as sort of coming from classical antiquity. And so many of these new ideas that were adopted, in fact, in some ways or another, contributed to technology and to economic development. And so among the many innovations that were introduced at the time is what is known as Arabic numerals, really Hindu Arabic numerals, better musket, a printing press, on and on and on and on. And what really counts here, of course, is not so much the beliefs of the patrons, nor is it probably fair to say that most of the population, if you want, the peasants and the unskilled workers, were particularly interested in innovation. But the people who were interested in innovation were people whom I call upper tail human capital, or UTHC, which is essentially people who had studied, who knew Latin, who could read, and actually read, which is not the same thing, and they were slowly being disenchanted, becoming disenchanted with the knowledge of classical civilization and looking for new ideas. And so what emerges, of course, and this is something that I have written about it at some length, they saw themselves as buyers of new ideas because they were citizens of what was known as the Republic of Letters that I discussed, as I said elsewhere. And so these are the people who bought books, who subscribed to encyclopedias, who corresponded with others, who eventually became members of local scientific and societies, and on and on and on. So there was demand for their services by people who created new ideas. And so that, I think, is mostly on the demand side of the market. And people convinced themselves, and this, I find this really striking, that not only that they wanted to replace the wisdom of classical civilization, but that this was actually going to bring about social and economic progress. And so it was widely believed that science would be eventually solve the problems of the world in the 18th century, which they, I think, eventually sort of came from Bacon and others, but that became sort of almost a consensus. And the striking thing is that, in fact, there was very little that science could do for most areas of production until, roughly speaking, maybe 1830, 1840. During the classical industrial revolution, there was the belief that they could, and people were unwilling to admit that, in fact, scientists didn't know enough to help them very much. In fact, what you see happening is the birth of the technical consultant in the 18th century. So here is an industrial consultant, somebody who was familiar with science, even though he wasn't actually formally trained, and he advised industrialists and landowners on technical and engineering problems. He supplied novelty to people who wanted to buy it. Okay, here's another one, a little bit later, Davis Gilbert, mathematician, but essentially consulted around broad math and physics, such as it was, to bear on how to build steam engines, how to build better water mills, and on and on and on and on. So that was sort of the demand side. Let me say something about the market structure as such. So in all markets, there are transactions costs. It's sort of standard Econ 1 kind of stuff. And of course, these transaction costs are incurred because purchases require resources to be consummated. Sometimes these transaction costs can be quite high, and therefore are a source of market inefficiency compared to a world in which there are no transaction costs, which of course is a completely mythical thing. And so in the markets for ideas, the equivalent of transaction costs are what I call access costs. And so access cost basically means if you don't have a piece of knowledge and you want to get it, it's costly. And so why do access costs matter? Well, here's a little table, you know, and so if you can look at the sort of propositional and prescriptive knowledge, and most of these things are sort of rather obvious, you know. If you want to access the propositional knowledge, why would you do that? Because, you know, you need science built on itself, and you don't want to rediscover reprove or rediscover known things. But of course, the cross-diagonal items are more interesting, and they are about how prescriptive knowledge, as to say, engineering learns from science, but also how science is inspired by prescriptive knowledge. One way or another, access costs are important. So what determines access costs? Well, we sort of have a good idea of what they are. They are depend on many factors, including, of course, storage costs. So it's if the knowledge isn't embodied in somebody's mind, it might be in a book or in a model or something like that, but these have to be stored and made accessible. This has something to do with the skewness of the distribution of knowledge. So in the extreme case, if there is a piece of knowledge, only one person in the whole world has it, so it's very skewed. It's very costly to find that person and persuade him to say so. The cost of actually getting to where the knowledge is, which is libraries, books, and so on and so forth. And then within the books, you know, how easy is it to find a piece of stuff that what I'm looking for? And so, and perhaps most important, I think, is that the transaction cost in the market for ideas depend on trust. So, can the person who's trying to sell you an idea, can he be actually believed? So that's an issue of a famous book by Simon Schaefer and Steve Chapin called Leviathan and the Air Pump. And in that book, they sort of talk about the discussion between Hobbes and the Baconians, such as Boyle. And so the question is, you know, we prove things by experiment, but why should I believe it if I didn't watch the experiment myself? So I have to trust the person who tells me I carried out this experiment. That's basically, and so the term that they use is that knowledge becomes collectively certified because we trust the person who, you know, used the vacuum pump to create a vacuum, that kind of thing. So a technology of trust then is a crucial component in the market for ideas. And in fact, we still, you know, this is the whole notion we have today about experts, right? There's a consensus of scientists and authorities that we have designated to anointed as such. And so I don't actually have to go, you know, and do this stuff myself, and I don't have to spend many hours looking it up, because I find the expert, and the expert tells me, listen, you know, this particular physical rule is true. And so I believe it because I trust that person. Now, but that trust is a convention, of course. And if it's often challenged and undermined by other experts, then access costs will go up. And so over time, what happens after 1500 is that access costs start decline, and it makes the market for ideas work smoother. One of them is already talked about is the printing press and the growing effectiveness of the postal system, which allowed intellectuals to correspond with each other. Perhaps the most interesting thing is what I call the codification project. And the codification project is based on the fundamental distinction between tacit and codifiable knowledge. So it's a standard sort of distinction we make in epistemology, and it's kind of sort of obvious. Much artisanal knowledge of how to make things is in fact tacit. An artisan doesn't write down how to make what he's making. You want to see what he's doing, you can take a look and see how I'm doing this. But he couldn't explain it to you even if he had to. That's sort of the idea. Now, if you can codify this, if you can write books, explaining how these artisans work, you will reduce access costs. And you can find what's on sale, sort of speaking, in the market for ideas. So books mattered, of course, as well. Encyclopedias, dictionaries that provided easy access to useful knowledge. But within books, people come up with all kinds of tricks that we take for granted. Alphabetization in handbooks, indexes, or very detailed tables of contents. We sort of got rid of that. But if you go pull out an 18th or 19th century book, there's 5 pages which give you each chapter exactly what's on it. It's kind of fun. So here is one example of this. This is published in England in about 1750. And this is a complete dictionary of arts and sciences. Okay, now this is actually fairly advanced stuff, but you can sort of see that among the many things interested, there are many of them that we would think today of as technology: anatomy, pharmacy, surgery, hydraulics, mechanics, pneumatics, and so on and so forth. So you could actually look this up. There's a fair amount of math in there. They're very detailed pictures. It's very useful. They sold over 1,000 copies, which means there was some kind of demand for it. But it, of course, reduced access cost. The most famous of these encyclopedias, of course, is this. This is the Grand Encyclopédie, which contains hundreds and hundreds of very finely done technical pictures. I actually was going to erase it. This is less well known, but even more detailed. This is the Description des Arts et Métiers. This was actually run by the French and funded by the French government. The Diderot d'Alembert Encyclopedia was a private enterprise. And it'll give you one example of what this looked like, and to show you how it actually makes this accessible. Okay, so this is the locksmith's art. And this is, I just drew this basically at random, But you can sort of see that there is, in fact, a fair amount of technical stuff in here. There's all these parts that goes into a lock, and they show you exactly, and then there's long descriptions of how these things fit together. And it's obviously somebody is codifying something that people knew how to do. Here are specialized books that are part of the codification process. This is about mining, interestingly written by a Frenchman, also most of the mines that he saw were in England. And this is a slightly later book about an elementary course in machines. And so more and more do we see very detailed and carefully done books that map tacit knowledge into codified knowledge and therefore make it more accessible. All right, now before I go on talking about the market for today, I want to very briefly say something about China, because this talk has been very Eurocentric, and I'm a bit hesitant because Ken Polman is in the room and he knows more about it than what I do now. Okay. Wait. I'm going to go back to, there we go. So I'm going to say something about the market for ideas in China, because I don't want you to think that the Europeans are the only ones that had anything like that. China has a very vibrant and active market for ideas indeed. Scholars could publish commentaries, encyclopedias, technical manuals, mathematical treatises. In fact, there is a famous market for books in Beijing on the site of what used to be a glaze and glass factory. And if you went there, and there's eyewitnesses who went there, you could find not just mostly classics, but also examination prep materials, which is kind of obvious, antiquarian items, but also a few technical books. So the great technical encyclopedias, if you were lucky and you could find a reprint copy, which was hard, could actually be bought there. So there's the famous Nongshu, which is an enormous document published in 1313, but it would probably be very expensive. Now, China did produce superstars, okay, or these polymasters. Among those, these are probably the most famous ones, Shen Kuo, Su Song, and Wu Shaoqing. But even after that, it produced many formidable intellectuals that really were in no way less successful and less creative than the great European ones. And so they were superstars in the Chinese market for ideas, but they share a characteristic that you don't see in Europe, and that is that almost all of them were government officials in the imperial civil service. So it's a market for ideas, all right. It's quite competitive. Yet certainly the examinations were extremely competitive, but it was a market that was there where there was little demand for out-of-the-box thinking. Okay, and even when there's a new school, so the famous Kaohsiung school, that was called themselves, evidential scholarship, what they were really doing, it was backward-looking ideas. How, Juchi was actually wrong or right in interpreting what Copernicus said. So it's very exegetical and very backward-looking. That is the way the market for ideas evolves in China. So it's not enough to have a good market for ideas. It has to be directed and incentivize the kind of thing that I was talking about before. So as I said, the incentive structure was very different, and it was largely conditioned by the examination system. And so you could think of it as a constrained market for ideas. Now, much like Europe, it has every once in a while, the government decides to suppress certain kind of information. So there is a famous thing called the literary inquisition, which is sort of a bad translation from Chinese, but there is, there's serious censorship. Now, there's censorship in Europe as well, but the problem is it's so fragmented that if your book couldn't be published in Italy, it could be published elsewhere. And in fact, the later writings of Galileo are actually published in Strasbourg and in Basel, where the Inquisition couldn't get to it. You don't have anything like that in China, where the government basically runs the country. And so that, I think, makes a big difference. So I'm going to basically skip much of this, but I'm going to talk a little bit about the market for ideas today and argue how it relates to the market for ideas that I described so far. So in many ways, I submit to you, the market for ideas today is a massively scaled up version of the market for ideas in the form that emerged in Europe in the 16th and 17th century. Now, scale is everything here, we all understand that. But the principles have remained roughly the same. And I want to give one example of a small technical change, which I sort of you'll find interesting. And that is this one innovation that may have changed the way the market for ideas worked. And that's the scientific paper, which we all produce. Not many people actually realize that it's a fairly recent invention, that until the 19th century, there were very few publications that we would recognize as papers. The first scientific journals, of course, were there. They emerged in the 1660s, but people either published short communications about new ideas, or else they published books. The scientific paper, as we know it today, actually emerged in Germany in the 18th century in the Annalen der Physik und Chemie. So this guy, Johann Christian Poggendorff, was the editor, and he was the one that introduced what we would recognize today as a paper. But even as late as 1900, most of the respected journals did not really contain papers but that we would today recognize. There were short communications, there were letters, and if longer than that, they became monographs. This is a nice way in which to show you how the actual structure of the market for ideas itself can promote ideas. Now, how about incentives? So have we solved the problem of incentives? And, you know, the patent system is, of course, everywhere. We live in a world of patents, ladies and gentlemen. In 2024, 3.7 million patents were filed worldwide, nearly half of them in China. This is an extremely interesting and ironic development, because in China, in fact, the idea of intellectual property rights is almost entirely absent until it was penetrate China with the Europeans after the contact between Europe and China became much tighter in the late 19th century. But even then, I think the real emergence of Chinese understanding and cultural acceptance that knowledge can be an asset from which I'm allowed to exclude you, that is actually something that is fairly rare in China. And so all of a sudden, in the past 20 years or so, their patents have just mushroomed. So it's quite amazing. Now, as far as propositional knowledge is concerned, of course, the incentives are vastly stronger than in the past. They're similar, there's just more of them. And they confer a great deal of prestige on the receiver, as we know. So the scientific community, particularly in the 20th century, has made an effort to create these incentives, to make people who create ideas come up with new ideas, okay? And so there's all kinds of distinctions. At the very top, of course, there are the most prestigious prizes, the Lasker Prize, Fields Medal, Balzan, on and on and on. The Nobel Prize itself, of course, was only established in 1901. Many of the other prizes came much later. But the recognition is that this does promote science. In Britain, interestingly enough, the idea became of ennobling people for their contributions to science. This did happen in the past. A few famous scientists were knighted. Isaac Newton himself was, and so was Humphrey Davy, Lord Kelvin, a few others. But it was actually fairly rare. In the 20th century, it becomes more acceptable. Here are a few examples. After 1980, it's become very common. And some of my economist friends have been knighted. That would not have happened, I think, in the 19th century. Other countries, of course, jumped on the bandwagon. So there's the Japan Prize, and as China established its State Preeminent Science and Technology Award. Some of these things are, of course, private, like the Nobel Foundation and the Balzan Foundation and so on and so forth. But many of them are actually awarded by governments in an attempt to stimulate science and technology, depending a bit on who is in power. And so, for instance, the National Medals of Science were established by Eisenhower in 1959, but they remain at the discretion of the president. So, surprise, surprise, none were awarded between 2016 and 2022. And if you think you're a candidate, wait a few years. So, as I said, the economics of winner-take-all prizes is, of course, important, not so much for the people who win, but for the thousands who don't, but think they might, and do their work for that reason. That is how the market for ideas works. The other thing, of course, is that the idea of open science, which emerged fairly early on, is still very much with us. And in fact, we live, I would think, what you might think of the market for ideas on steroids, so to speak. And this is a little bit surprising, perhaps, because in 1963, Derek de Solla Price, one of the great historians of science, wrote a book called Little Science, Big Science, in which he warned that the world eventually, he said, the supply of new ideas would come to an end, simply because it's been growing so quickly that it can't keep growing at this rate. And so then he predicted that that would lead to a decline in discoveries and potential crises. I don't think actually that will happen. So there you have Derek Price, a wonderful guy, and this is his book. But he turned out to be wrong about that, amazingly enough. In 2023, 3.3 million scientific articles were published worldwide, which is, 50% higher than in 2014. And so the estimates today, as I said, for the more later thing, somewhere between 3 and 3.5 million refereed papers published each year. Now, eventually, that will have to slow down. It can't keep growing at this rate forever, but it went much later than Price thought, in part because I don't think he could even imagine the fantastic growth of science and technology in China. But there's this interesting metric that Price suggested, which is that he wrote and he suggested that in 1963, in his book, he says 80 to 90% of all scientists who ever lived are alive today. And this is known as the coefficient of immediacy. I'm not sure why. A striking illustration of the scientific enterprise. It's still true today. I think the number is slightly under 80%. It's something like 76 or 77%, but it's, you can Google it. But the supply side of science is clearly thriving with no signs of the market, this market idea slowing down at all. And of course, there's access cost today. This is so obvious to anybody who is alive today. It's a long, the slow postal services and the clumsy printing presses have been replaced by a system that nobody could have imagined even 50 years ago. And so what about access cost in our own time? Will access cost go to zero with internet, Google, and AI? And I want to sound a brief sign of warning here before I sort of wind this up. Now, storage and search costs, as everybody in this room knows, are essentially negligible. But the major constraint we're facing are what I call verification and selection, right? To separate the wheat from the chaff, to tell information from misinformation, and recognize when our information machinery is either misleading or hallucinating. More serious, I think, and this takes me back to the Schaefer and Chapin book, is that AI makes fake news look like the real thing. And that may undermine the sort of technology of trust that they identified. And it may weaken our willingness to put our faith in experts. And of course, if that's the case, it will raise transactions cost. Now, of course, if the supply side is thriving, so is demand. The demand for new ideas will come not only from the desire of nations to keep economic growth, but also because we are facing, unprecedented challenges that will require a great deal of innovation if they're solved, because the political system surely will not. And those are, of course, the global climate change and associated phenomena, and demographic change, and the global aging of population, and the problems associated with that. But that, I'm afraid, will be another story. Thank you.